Good afternoon, Jan.
Michael, good afternoon.
How do you do, sir?
Doing fine. What about you?
Very good. Very good indeed.
That's a very long time ago.
Yeah.
By the
Yes.
way, Happy New Year.
Happy New Year. Yeah, it's already the end of the month and we're
Yeah,
just getting kicked off for 2023.
yeah. So, how was
Yeah.
the trip?
Yeah, that was a really relaxing trip. Yeah, so we took a cruise through the Panama Canal, going for over 2 weeks there. And it yeah, there were just many days that we were just sailing. There were no stops, but and so during those days, just completely shut the brain off, do some reading. Got through 5 books, um,
Okay.
but yeah, the transit itself is that is actually a really interesting look into the engineering and the logistics. You know, basically how modern civilization runs is because of things like this. Um,
Yeah.
so whenever I click on the one click buy on Amazon, it just that's what it sets in motion. It's like wow, it's crazy stuff.
Yeah. All these ships transporting goods through Panama Canal.
Yep, yep. And actually, as
Mm.
we were transiting, we sailed past a huge green tanker. It said Evergreen on the side, and I said, "There it is." It wasn't the Ever Given. It was the Ever Laden, but it's like,
Yeah.
aha! Yeah, watch out, it's turning sideways. Um, it was fun.
Unblock everything.
Yeah.
And you managed to live for so long without internet.
Yes, yeah, that was actually the best part. Yeah, sometimes, some days it was a little bit rough. I really just wanted to see a unit test fail and then make it pass. That's just like yeah. Um, but but yeah, really forcing myself to just be in the moment. To be with my family um, rather than try to pay attention to this and also the people around me. Yeah. So I
Yeah.
hope to be able to stay in that mindset for a little bit longer, but I can already feel myself getting pulled back into, just paying attention to everything all at once.
Yeah. Yeah. And I need your help. So,
Yeah. Well, the places where it's really bad for me is news, of course. So far, I've not
mm,
gotten sucked back into news, um, and um, and it used to be social media, although Twitter's dead now, so I don't have that to worry about. I mean, it's practically dead.
mm,
Yeah, I used to use an app called TweetDeck. Well, no, TweetDeck was an old app. Um, anyway, I forget which app I used to use now, but I've already uninstalled it because Twitter disabled all popular third-party apps. So it's like, okay, as I was getting back in, I was like, okay, I probably should check to see if anybody's messaged me in the past few weeks, and and there was one mention, but it was somebody just quoting something from the book, and so I was able to pop in there and say, hey, anything you like. He didn't respond to that, so I'm like, okay, we're yeah, it seems like everybody in my circle is starting to move on. They're moving on to Mastodon. I'm not ready to take that leap yet, but yeah. So yeah, tried out the actual Twitter app again, and say yeah, this is the reason that I didn't use it. So
yes.
um, so yeah, I
So
think
actually, Elon Musk did you a favor. He gave you peace, rest
yes,
and peace.
yes,
Yeah.
yes, indeed. Yeah, well, I'll let everybody else
Yeah.
figure out what's going to happen now, and
Mm,
then I'll jump back in. I'm not really an early adopter when it comes to social media. I mean, I
okay.
was on Facebook before the rest of my family, but then once my family joined, I was like, nah, I don't want to be on Facebook anymore. Um,
Mm,
but LinkedIn is actually my current
mm.
social network of choice.
I try to avoid it.
Mm-hmm.
I just use it for the things which I really have to know, or where I'm part of an association or so, and I need to
Mm-hmm.
to be in some private groups, but
Yeah.
for the rest, because otherwise there is no time left. You
Yeah.
are much faster, but I need my time to do things. So as I wrote you, let me struggle one more week. Yeah. What am I struggling most with?
Yeah.
I've been struggling a little bit. Luckily, I had some time when you were not there.
Mhm.
But before you got back, yeah, my customers were also back, so they are. But okay, the most trouble I'm having, that might not be the case for other people, so that's a good thing.
Mhm.
I'm too much in old technologies, VB6,
Oh,
Visual
yeah.
Studio, Visual Studio 2005, and things like that. So the big trouble is my very limited knowledge of TypeScript
Mhm.
and JavaScript. You use advanced constructs there,
Yeah. Yeah.
and then I have to translate it to the state-of-the-art C#.
Uh-huh.
So if you have lacking knowledge in both
Mm.
in both things, yeah. So one of the things I encountered there was, what was it, a signature index in TypeScript, which is like a dictionary actually.
Oh, okay.
Where you
Okay.
can,
Yeah.
yeah. Well, it's very nice, but you find it in source code. But before you find out what's the name, once you have the name, you can look it up
Ah.
on internet.
Yeah.
But before you find out what's the
Yeah.
name,
It's just this pattern.
yeah.
Well, good morning,
FC.
Faust. Good to
Good
see you
morning.
again.
Thanks.
Yeah, we got back from my 2-week cruise, and so we're finally ready to kick off 2023.
Awesome. Well, don't let me interrupt. I mainly logged in to listen today.
Okay, cool. Yeah, so we're getting up to speed on the work that Jana's been doing on SQLite.net, or on the SQLite storage of Jinaga.net. So,
Yeah.
yeah, cool.
Mhm. Okay. But so the biggest problem there
Mm-hmm.
is the translation of the data structures.
Right. Yes. Yes.
So
Yeah, C# uses the C++ inheritance style, whereas TypeScript uses union types to accomplish the same thing.
that's
Yeah.
that's one of the big issues. And to give you, wait, because that's gonna be too big to share that window. If I make it a little bit smaller, let me share that. Jinaga.net go live. And that should be, wait, which one is it here? Don't need that one. Don't need that one. For example, here. Wait, where is it here? So we have this result description builder.
Mm-hmm.
And then somewhere, wait, I'm gonna move this to a different screen. Then I can see my questions at the same time. Do you still see the?
Yes.
Okay.
Yeah. It moved the view with it.
Yeah. Okay.
We saw a little bit of digital inertia going on, but
somewhere we had a parameter that was a union of a string and a number.
oh, right. Yes. Yeah.
And it must be this one, I think. New query description.
Yeah. That would be for the parameters, I believe.
Yeah, for the parameters. So I say, okay, just make it an immutable list of object.
Yeah, we want to be as close as possible to SQLite-net, how it handles parameters, which is probably an object array, if I were to guess. So that's probably the right choice.
What I tried to do right now was do, in fact, a translation which was as close as possible to the Java Jinaga server.js.
Yeah.
Because if every implementation is going to be completely different, I even try to follow exactly the same names.
Yeah, that's true. Yeah, I think that's probably the right data type. I would be curious to see how SQLite-net handles parameters. It might actually have a type-safe way of doing it, but in this case, since we're building up some SQL text, we wouldn't be able to use anything that's clever and type-safe. But yeah, let's stick with this one.
Because these parameters are just going to be used directly in the SQL string.
Yeah, the SQL string should have placeholders. And then you pass the SQL string and the array of parameters to SQLite-net.
Yeah. So, and then it gets a lot worse when we get to the projections.
Yeah.
And there I've been from one ID to another.
That's where the data structures were different, and a couple of months ago now, I changed the data structure in TypeScript to be closer to the .NET data structure for projections, and use a little bit less of the clever JavaScript stuff. So it wasn't that it could be an array or an object based on whether it's a composite or, and then also the fact that the name of the property that it was trying to project into was part of the projection in some cases, and so you had some clever TypeScript things going on there. So in the new data structure in TypeScript, that's cleaned up a little bit. It's still not perfect one-to-one with C# because of inheritance, that kind of thing. But the but yeah, at least the objects are about the same shape. And then then just yesterday, I created a branch in Jinaga server that starts to take advantage of that new data structure. And so in Jinaga server now in that branch, you'll see some changes to generate SQL from the new data structure. So that might be coming a little bit late for you, but it's there.
No, I was thinking I didn't see because I updated all the local code from GitHub, and because there are big differences between the specification structure in .NET and in Jinaga server.js. I see that in Jinaga server.js you declare the interfaces as well in the file where you do this. Where you make like this query description.
Yes, yeah.
You have multiple definitions of the same interface. While in .NET, so I found, where are they here? Here you have them, the collection projection, compound projection, field projection, and simple projection.
Yeah.
Now,
and they're all pretty small.
And they all inherit from there.
Yeah.
The one that I currently need is just this one. But it has just a tag, while what is it called? It's called singular projection in Jinaga.JS, and there you have a label and a field. The label being the unknown, in fact, and the field that you project, like department.name.
Yeah.
But so I was looking into these projections in .NET. I haven't gone through how you got from the link syntax to the projections.
Yeah, which changed in December, I think. Maybe that was November. Maybe it was December. Yeah.
So I don't really fully understand the projection structure in .NET. But so the question now is, how do I proceed with these projections? Would it be easier that I just make simple classes and I keep them in the SQLite store? These classes might not be fully compatible with the projection in specification, but then I just copy the data, and so everything stays local to SQLite store.
Yeah.
Or do I use the projection structure that you use in the specification class?
Yeah. Okay. There are pros and cons to both of those approaches. So first of all, the word tag versus the word label. Tag was an earlier idea because I started with the link queries, and so I took the parameter names that were inside of the lambdas, and what I needed to have was just a unique identifier for a value that I could put in the symbol table. And the parameter names in the lambdas were not guaranteed to be unique. So I didn't want to just come right out and say variable, but yet I didn't put any code in there yet to allow them to have collisions and account for that. So still some testing to do there. Anyway, that kind of thinking led me to, let's not call it variable. Let's just give it a name that kind of represents this. This identifies a thing, but don't take it too seriously. And so I came up with tag. And then, if you remember taking a look at the way that link turned out, I said, oh, wait a minute, this gives me a new way of thinking about specifications in the first place. And so, I came up with the specification language, and in that specification language, came up with the idea of each one of those matches having a label. So
the unknown.
Yeah, the unknown. Yeah. And so, that collection of unknowns plus the collection of givens, taken together is the set of labels. So, have the idea of, here's a graph, label different points in the graph. Some of them are inputs, and then you trace into the outputs, and then you can just switch what's the input and which way you're tracing in order to do inverses. And I was like, whoa, this is so much simpler. So basically that really solidified the idea of label. And so at first I was thinking tag and label were different things, but actually as I refactored, they became pretty much the same thing. So where you see tag in that code, that really should be label. And then where you see name in the TypeScript code, that's where I was using a trick of TypeScript, a trick of JavaScript, where I could go ahead and put the name of the property that I'm projecting into the projection itself, and just say, here's an array of those things, and then in the new code, I decided let's not be quite so true. Well, actually, you know what? I think I might still be using that trick now that I think about it. anyway, we'll take a look at that code in just a second just to see.
Yeah.
But that's not a trick that you can use in C#. So instead, you would have a dictionary of name to projection, and that's how you would accomplish that rather than putting the name property in the projections. So okay, now getting back to kind of the pros and cons of the two approaches that you just talked about. All of this stuff is really indicating that there is still more refactoring to do in Jinaga.net to get it even closer to Jinaga.JS, because now Jinaga.JS represents the more refined thinking around the specification data structure. Used to be the other way around. So I keep on picking up one foot and then putting it in front of the other instead of just bringing my feet together. So it's like, oh, this is better. Wait, no, okay, wait, no, that's better. So there's still some refactoring to do there. So pro of creating your own data structures and copying is that when we do that refactoring, the refactoring touches the copy stuff, but it doesn't bleed into the rest of your algorithm. And con is that you've got more data structures to keep in your head while you're trying to understand things.
Yeah, because if people are going to use it on different databases,
mm-hmm.
If we want to use this as a reference implementation, then it would be nice if it is as much as possible independent of the rest of the structures,
mm-hmm.
I guess.
Yeah. So that seems to be outweighing.
Because also the problem is also the other structures are different on different platforms.
Mm-hmm.
They are changing, so they will never be fully documented.
Mm-hmm. Yeah.
And one thing is a big problem with lack of knowledge for me. And the other thing is, I think for the others, missing documentation.
Yeah.
Which is normal because it changes so fast that I think in the end, when this is implemented, that I should write some documentation around it to allow others to translate it to other languages.
Mm-hmm. Yeah. So I think that whole argument is starting to say, all right, having a copy into another data structure that's specific to this, that seems to be the better approach.
Yeah, because you wrote that document. Which one was it? This one, which is
yeah. Let me see if I can. Oh, did I lose you?
Wait, I show you the one with the diagrams.
Yes.
Yeah, the department and the company. Because that one is quite nice, but even there, I think somebody who has not been following for a long time how to build up the data structures and where it comes from is still quite complicated.
Mm-hmm. Yeah, it definitely is.
On top of that, let me go back to the questions. In the Jinaga query language,
mm-hmm.
There are a few constructs which you did explain in videos, but I don't find it back without looking through all the videos.
Uh-huh.
And as I didn't go through the processing of these queries yet, I just last time went through the parsing of the specification language
mm-hmm.
Through the structure, and that one is really nice. and it's not so complicated. It's
Oh,
quite nice to understand.
okay, good.
No, I don't know anything about
Uh-huh.
parsing, but I don't know whether that structure that you used with all these extensions, whether that's a common pattern. I've no idea, but it's
Yes.
really nice. Like there should be a space, and there should be that, and it's nice, and it's very readable. But so for the Jinaga query language, I haven't been going through how it works. And for example, at a certain moment, we could add a hash. Was that directly in the query language as well?
It is now. It wasn't there before. But yeah, let me see if I can pull that code up.
For example, we have these projections, and one of them is a hash projection.
Mm-hmm.
And I was just looking to that singular projection, but I don't find anymore why we need that hash projection.
Yes. So the hash projection is primarily for somebody using the running server and hitting the read endpoint, so that they can get back the hash of one of the facts that they're projecting. It's not something. Well, it originally was not something that you would use in development. However, I think it did add support to that for that to link. So now link, whenever you use the j.hash function, it will compile down to using the hash projection.
Okay, and what was that j.hash doing?
Yeah. So j.hash gets a it takes a fact, and then it gives you back the string hash of that fact, and it's the consistent hash that every implementation agrees upon, and that's useful for. Actually, I'm trying to think. Did I just do that in Jinaga.JS, and I haven't done that in Jinaga.yet? I don't know. Yeah, I can share my screen, and we can kind of look that up. See if that's.
Stop this sharing.
Okay, so this, I was just looking through the specification parser while you were talking. This is Jinaga server. Let's open big old Visual Studio to do Jinaga.net. Okay. All right, so we've got a specification parser, and this one. Okay, this is the link. I think I might be on an old branch here. Yeah. That's old stuff. Okay. So now let's take a look at so what was the that's over for. What was the name of it?
j.hash.
Okay, yeah, so let's start with the big ol' Jinaga class. So this is the thing you create an instance of. Yes, wrong one. Okay. So you create an instance of this class in order to access everything. So you've got your facts, query, watch. Okay, so yeah, I think I only did this in no, I know that I've got it in here. Yeah, so let me go to the test. This is always the so compute hash. This is computing the hash of a fact. Yeah. So but it's serializing it and doing that reference. Okay. Okay. I at the very least intend to make this capability visible to the application developer. So let's take a look at the TypeScript version of the same thing. And if we look at Jinaga.JS, we see there is a hash static function. So if you've got your instance of Jinaga and you say j.hash, then it says, oh, you mean this one. Or you can just say Jinaga.hash, either way. And so this will do the serialization if it needs to compute the hash, but it also caches it, so you don't have to serialize every time. So the neat thing about this is that if you end up doing a j.hash inside of a specification, then what it will end up doing is so let's go back to specification, and we've got specification parser does all of that that recursive descent parsing that you were talking about earlier. But there's also the one that that does the interpretation of some TypeScript code. Let's start with the tests again, because it's always easiest to do that. So here's specification spec. So this, okay, yeah, this is testing parsing the text. Am I in the wrong branch here? Yeah, I'm in 501, which is now merged. Why am I not seeing it? I'm trying to find the... okay, that's right. It started from model. So do I have model in here? Here's model TS. Yeah. Oh, no, that's for a test. I need to figure out where that code ended up. But
you have somewhere a secret version.
Yeah, so right here, model given match. Yeah, so this type of specification. So if we go in here, given TS. Oh, okay. I need to rename this. It's given is not the most important thing anymore. Yeah, given used to be the starting point, but then I added the capability of giving type information about your model, and so that's so now it starts with the model, and then .given is the next thing. Okay, so let's start from the beginning here. So, so here's the model that we described right here. So it says there are all these different types. Each one of these types is described by a TypeScript class. It gives you the static, what is the string version of the type, and then what are all the fields and predecessors. Add those to the constructor, and that's it. So that's all compile time information. Runtime, you need to know, okay, for this particular type, I've got these predecessors. So user, prior, blah, blah, blah. And the predecessor type is this other class that you should also see somewhere in the model. So this creates kind of that type graph.
Michael, but why? I know it's in the test directory. Okay. Yeah.
That's where. Okay, yeah. This model is a specific example. Yeah.
Yeah. No, I was thinking, why do we have that?
Yeah.
That specific model in there, but.
Yeah. Yep. But yeah, you're right. This is just for test. In the actual code under test, we've got the model class. So we can declare models, and then starting from there, we can then say .given and build up a link-like query in TypeScript. So given a company, now company is the first parameter of the lambda. But you could also do things like given two things. Yeah, right here, given a company and a user. So now those are the first two parameters. And then the last parameter is your fact repository. So very similar to how in Link you get your fact repository whenever you do a join. Here you're doing that whenever you do the equivalent, which is match. So given these inputs, match on facts of type. So just like fact repository in Jinaga.net, facts of type. Yep. There's the type, and then you do join, which is the equivalent of where in Link. So yeah, that is the fact of type that you're getting from the repository, but then you join it with other labels that you already know about. So in this case, givens. Okay. So all of this is getting down to, okay, here's select. So select does the projection. So now that I've got facts of type office, I'm going to select and I'm going to give office a variable. I already have a variable for company. So inside of here, I've got access to office and to company. I'm actually not using company, but I could select properties of company. So then I can do several different operations on it. So get a field that leads to a field projection, or continue down facts of type, and that gives me a collection projection. So I'm going to project into a collection of presidents and run that specification to get that collection. And I could just select the fact itself. So like right here, I'm selecting the fact itself. That becomes a singular, or actually I think I call fact projection is what I call that in the new structure. Simple projection is what you're seeing in Jinaga.net. And then the
singular projection.
Yeah. So then we've got hash. I think I've got a test that is for hash. Field composite nested. Maybe not, but yeah, when I do select, I do this 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 crazy trick, since I don't have reflection, I do this crazy trick of using proxies in JavaScript. But yeah, so right here, I create different kinds of proxies as you are navigating through. So it starts off with creating a fact proxy, and then based on what you do with that proxy, are you trying to get a property? Okay, that can either be a predecessor or it can be a field. So it figures out which one of those two it is, looking at the model that you've declared, and then it will give you a fact proxy if it is a predecessor. Otherwise, it will give you a field proxy. So then the other thing is, if you end up using this function here, then and so this is when you use j.hash, it tries to hydrate the it tries to basically write the object back out. So it serializes the fact and then computes the hash from that serialization. So along the way, it comes through here, and so if you end up coming through here, it's going to say, oh, wait a minute, you are actually inside of a specification. So what I'm going to do is use this symbol, which is kind of like a property name, except it's hidden. It's not just a plain string that you could also type in again. It's like, no, this specific symbol. And I'm going to basically store the hash in that symbol. And so that means that back here now you're going through that proxy stuff, and you say, okay, I just took the hash of that fact inside of a specification, and so I'm going to project that into a first of all, a hash proxy, but then when I get it back out, it's going to say, okay, that's going to become a hash projection. So just return the hash of that fact. So
and why do we need, as an end user, to know that hash?
Yes.
What's the use of it?
The primary use is so that you can record the identity of a fact without having to do a full comparison. So, for example, in React, in JavaScript, the keys of different elements, like if you want to project a whole bunch of objects into a list, each element in the list has to have a key that's just a simple value, and usually a string. And so React is going to, when it re-renders that list, it's going to look through the list that it's trying to re-render and say, okay, that's the same one, so let me just re-render that element. Or this key that I used to have is no longer in the list that you've given me, so I'm going to delete that element from the DOM. So that comes in quite handy in React, but then there are other patterns where you've got the ID of an object and it's in some kind of a dictionary, and you want to be able to look it up, usually in some sort of user interface scenario.
Okay. So in .NET for the moment, it's not really useful right now.
Yeah, I thought I remembered doing that, but so we've got our hash projection. Where is my hash projection?
I have it. I have it. So you should have it as well. Wait, or was that in the Jinaga server? It's my Visual Studio gone here. If you go to projections, it was in. Was it compound projection?
Yeah, so compound projection has a dictionary of names to projections. So that's as opposed to sticking the names into the projections.
No, projection, no. Match. No, the hash projection is just in Jinaga server.
Interesting. Okay.
It must be that you have it in another branch. I only looked at the main branch.
Yeah. Okay, so when you say Jinaga server, I immediately go back to JavaScript, but that's not what you mean.
Yeah, JavaScript.
Oh, okay, yeah. Yeah, so here I should see that it's just relying upon, like, let's go to the Postgres stuff.
Yeah.
So
the specification results. Yeah, and I think there somewhere you have an interface definition. Right, where is my copy here? No, it's in the virtual machine. Too many things at the same time open here. No, the Jinaga.net there. Yeah. Where was that? Path condition query at edges. Yes. Specification projection.
Yeah, I think that the Postgres SQL generator does not handle the protection of type hash.
Yeah.
So here it could be, the type could be composite, fact, field, or hash. And it's only handling field and composite. And that's because these were the two that were useful from the text, but not. But then I added fact and hash in order to make the runtime more useful. And I think I added those first on the .NET side. No, I added them on the JavaScript side.
Wait, where was it here? So much code.
Yeah, I know it.
Where was it? At path conditions? No. At edges? No. Yeah. If you go to create result descriptions there, which is in SQL result TS, and there on line 647. Yeah. A little bit down. Yeah. You're on 655. There you see projection type is hash.
Okay, right.
Yeah.
Okay, right. And so that's because both field and hash are singular projections. So let's kind of talk about this thing. And so you see when I navigated to singular projection, it went to specification.d.ts. This is inside the distribution of Jinaga.
Yeah. And there, in that file, you define also The hash projection on line 33, so a little bit higher.
Yeah. Yeah. This is a compiled file. Let me switch to the original source.
Line 31, you have hash projection.
Yeah. Yeah. Let me switch to Jinaga, the source code where this is defined, because this is the compiled, so that's why it's in dist. Yep. And that came from specification. So we go specification.ts, and then in here we can talk about hash projection. Yeah. So somewhat easier to read. So we've got field projection, hash projection, fact projection, and composite projection, and specification projection. So we've got 5 different types of projections, so the C# equivalent is to do an object hierarchy for these. But in TypeScript, we can do unions in order to bring these together into some common umbrellas. So a component projection is any kind of projection that can appear inside of a composite. So start with let's start with the simple ones. So the fact projection is just I'm going to select that entire fact and put that into some result of the projection. But then I could say fact dot property, and that gives me a field projection. So here, instead of just the label of the fact from the rest of the field property, you also say this particular field in that fact. Hash projection is take the hash of that fact, so it's still just the label. And then we get into the complicated ones, the composite projection and the specification projection. So let's start with the composite projection. This is when you select an object that has several different properties, and so the properties each have their own name, and they are themselves projections. But I don't allow just any kind of projection. I allow only specifications and singular projections, where singular is a field, hash, or fact. So basically, that excludes a composite within a composite. That's the only one that's not represented there. So I might actually go back and say, you know what, there might be a good reason for a composite within a composite, but this kept things a little bit easier on building back the results. So singular, these are the ones that give you back just a single value. The single value of that field, the single value of the hash, the single fact itself. And so when you end up doing that text and you select this thing, you could either say I want to select this JSON object, so you get a composite, all these different named projections, or you say I'm just going to select this one singular value.
Yeah.
So that's kind of the reason that they're grouped this way. So a component can be any one of those singular projections, or a specification, kind of a child specification that gives you back a collection. And then this syntax right here, this is meaning take that component projection and stick a name onto it. And so this is the kind of the JavaScript trick that the fact that in JavaScript every object is really just a property bag, and you can just stick new properties into it. So this is TypeScript saying, yeah, I want to do that, but I want to tell you exactly what it is I'm doing. So yeah, add that name. And yeah, as I think back, the reason that I did this instead of doing the dictionary approach was because I needed to preserve order. I can't remember exactly why I needed to preserve order in here, but yeah, that way I can just have an array of these named component projections, and that's my set of components inside of that composite.
Yeah. Okay.
So comparing that to the C# hierarchy.
You have projections, and you have collection, compound projection, simple, and match. No,
Yeah.
match not.
So let's start with simple projection, because as the name implies, that should be the simplest one. So this maps directly to fact projection, where label is tag.
Yeah.
So just some renaming, and we've got that that one. And then we've got the field projection. So in this case, tag is label, and field name is field. We're also keeping track of the C# runtime type because we're using reflection all through this. So you're not going to care about the runtime type when you're talking about SQL. So that could be one of those fields that you just kind of drop during that transition layer. So another good reason to have a translation layer, so you don't bring in concepts that are not important. So hash projection, do not yet have a hash projection, but that will be coming at some point. I'll give you a chance to get your stuff done before I add that back in. I don't need that capability quite yet. And then we're left with composite and specification. Let's go with composite next. So that's called compound instead of composite. So again, I should probably rename that to composite. But yeah, that's got the dictionary of named projections, as opposed to doing the array of projections with a name added to them.
Yeah.
And then finally, the specification projection. That is the collection projection. Yeah. So there you've got your set of matches and your projection for the next specification down. So same thing here, matches and projection. So a whole bunch of joins give you those matches, and then .select at the end gives you that projection.
Okay. But just to have a recursive specification.
Yeah. Yeah.
Okay.
Yeah. So that's kind of the mapping there.
Yeah. I think that should help me to get through that.
Yeah. Would it help to do the renaming in .NET first, and then you can more closely map one-to-one?
Now that I know it, and I can easily adapt it afterwards, because I'm just going to copy the fields in.
Mm-hmm.
And for my own structure, I will use the naming that you use in Jinaga server.
Okay, yeah, perfect. Yeah.
So
yeah, this actually is in Jinaga, not in Jinaga server. So this is Jinaga.JS.
Yeah. Mm-hmm.
But yeah, you're looking at Jinaga server when you look at the projection, or turning this into SQL. So yeah, I see why you say that.
what else did I have? Yeah, so the full structure of the Jinaga link syntax. It would be very nice if we could completely document that.
Yes.
The union I had. Oh yeah, this one. Let me share that again.
Okay.
It's just probably a stupid question, but it's one of these things where I say why. If we go to where is my SQLite here? SQLite store. Here. Fact by label is a type that we are using a lot throughout the code. And it's actually just an immutable dictionary on string and a fact description. So in TypeScript, you can just redefine it, and as in you give an alias, a new type name for this type. But in C#, apparently the only way which I found to do is using an alias using. But that means that you have to put it all the way up. So if you put multiple classes into your file, it's completely out of the way.
I see. Yeah.
And so even is there a better way to do that?
No, I don't believe so. In fact, I have not actually seen this this type of structure. I don't know when they added that capability.
Yes, because like this, if we go to all the references, why is it? No, I just need to see where.
Yeah, I use immutable dictionaries all over the place. But yeah, an immutable dictionary of string to fact description is a very specific thing.
In current document here. So, because actually the known facts is of the type fact by label. And so that known fact comes back everywhere.
Yeah.
In my at edges, in my create result description, you also have it here. So because it's just an immutable dictionary, there is no way to. Otherwise, you have to put there the whole definition,
right?
The whole
Yeah.
type definition.
Well, there is one other alternative, and that is to actually declare a class that has an immutable dictionary, and then does all of the things that immutable dictionary does.
The class that inherits from immutable dictionary.
Yeah, I don't think inheritance would work in this case because immutable dictionary.add returns an immutable dictionary. So immutable dictionary.add doesn't know to return your derived class. So rather than inheritance, use composition. So the immutable dictionary is a private member of the fact by label class. And then fact by label has add and get and just the methods that you use. And so it knows to wrap that next immutable dictionary into a fact by label.
Okay, that could, yeah. Just wrap it in the new class.
Yeah. I think that would simplify things. And then there might even be then some additional types that would make sense out of the tuples that you're returning. So I think I in TypeScript kind of ended up with those return types over several iterations of test-driven development and refactoring. But I didn't go to the next level of saying, okay, this is a tuple that I'm seeing an awful lot. I should probably give it a name now. So you might be in a position where you can say, all right, this group of things makes sense and has a name, so I can think of it as this thing.
Okay.
Yeah.
I'm gonna try it with composition and see where we get with that. Let me see.
Yeah, I think I had an example of that that was something like a specification context or something like that. Yeah, I don't remember where I used that. Yeah, but yeah, there was in this case there was a bunch of parameters that I was passing to everything. I said, well, let's just take all those parameters and shove them into one object. And then as I started thinking about what that object represents, it represents the context of the specification builder at this point, I think it was. So that concept got its own name.
But I can find out. That should be okay. Wait, because we are running out of time. Let's see whether there were urgent things. That's not urgent. No. Okay, the rest should work. One of the strange things I found out. So in where was it in Jupyter, the .NET Interactive?
Mm-hmm.
No, in Post. Yeah, I was working with Postman. And there so from department, given his department, I go back to company. So I look for a predecessor. If I'm correct, I tried the same thing from .NET Interactive, looking for a predecessor. Or was it in the .NET client? In the .NET client.
Yeah. Okay.
And there it doesn't work, and I think the reason is because, of course, you're looking for a predecessor. So the predecessor is already should be in your local database.
Yes. Yeah. So I think.
But if you send it while on the server, it has to work. Because you have to be able to retrieve things.
Yeah.
But on a local client.
Okay, so the I think you even now get an error message that says that you can't directly select this predecessor. Instead, give it a label. I know I've put that error message in there in at least one place. Basically, the idea is that the specification is broken into two parts. The first part defines a bunch of labels and the conditions among them. So that gives you a set of tuples. And then the second part is the projection that turns those tuples into whatever target type. If you select a predecessor in that projection part, that is actually attempting to go back and modify the first part. So it's saying, so if you let's come up with an example. So you've got a student registers for a course, and so you say, okay, well, which course? So the course is registration.course. What you really intended was that course should be part of that first part. It should have a label, and it should be related to the registration. And so it originally actually went back and did that. So it said, oh, this is what you mean. Let me go back and change that that description of the labels. But then the edge case that I ran into was if that was actually a multiple predecessor scenario, then you so you've got an order with several different order lines, and you have those as predecessors so that you can lock in that order and say, okay, I'm submitting that order. I can't add any more lines to it. So that's the set of lines. So then if I've got that and I say that I want to select the order line, then I end up with returning more results than I would have before. So it changes the number of objects that you get back. In fact, if think not let's, instead of thinking about collection, think about optional. If you select the predecessor and for a particular fact that predecessor doesn't exist, it's null. Then having that label with that condition would just exclude that result. But that's not what you want. You want to actually have the result. So basically, this forces you to be explicit about it. Do I want to exclude the result? In which case, I will use the label, or do I want to really just give you back an empty collection, or a collection containing the one optional? In which case, I will do a sub. What did I call that? Not composite, not compound. Those were the objects. I would do a child projection.
Specification projection.
Yeah, specification projection. That's the one.
Yeah.
So it's just forcing you to be explicit instead of making an assumption and then in some cases getting the wrong behavior.
Yeah, I'm not sure that was the one that I should try it again. It was one of the things that I doing some testing.
Mm-hmm.
Okay, because we're running out of you have to go to work. The rest are just small things which I keep for next week.
Okay. All right.
Okay.
Well, keep at it.
Michael, thank you.
You're welcome.
Yeah, thank you very much. This will allow me to struggle some further to get some more results, and then see you back next week. But it helps me to get at least a little bit up to speed, because once we get into Maui, I'm gonna need all that C# thing anyway.
Yeah.
So it's better to struggle now than later.
Yeah, that is true.
Okay.
Yeah, always all modern C#.
Yeah. Michael, thank you very much, and see you next week.
Thank you, Jan. See you then.
Okay. Bye-bye.
Bye.